This lesson is introducing rates and ratios. Some of this should be a review from your grade 8. If a car is traveling at 60 kilometers per hour, is that a rate, a ratio, or a percent? Think about it for a minute. It's a rate. We'll talk about why in just a moment. The number of apples to oranges is 2 to 3. Is that a rate, a ratio, or a percent? Well, the giveaway is that it's written as a ratio, so that is clearly a ratio. Now, 24 out of 26 students were present in class today. Is that a rate, a ratio, or a percentage? Well, you're on track if you guessed that we hadn't used percentage yet, and so that should be the third one. Yes, that is a percentage of students that were present that day. Let's dig in a little bit deeper. What is a ratio? A ratio is a comparison of like quantities with the same units. For example, 3 to 4, or it can be written like a fraction where you've got 3/4, are both read as 3 to 4. Just like fractions, ratios should be written in their lowest terms, so you always need to reduce them down. So as an example, if you've got a ratio of 3 to 6, both 3 and 6 can be divided by 3, and you end up with a ratio of 1 to 2. Now let's try something. Suppose there are 3 Messi fans for every 4 Ronaldo fans. Write the two forms of a ratio that show this data. Well, my first reaction would be to say that I've got a ratio of 3 to 4 Messi to Ronaldo fans. But I can, of course, turn it around and say I've got a ratio of 4 to 3 Ronaldo to Messi fans. Fundamentally, they're saying the same thing. You're just putting one number in front of the other, but the ratio is still going to mean the same thing. Now, what if the units are different? First, we need to convert both the numbers to the same unit. Then we write the ratio in its simplest form again. So let's try it. Supposing you were comparing the ratio of 2 years to 15 months. We can't say it's 2 to 15. That's not what we're doing. We have to convert that 2 years into months. So we've got 2 years is equal to 24 months, because there's 12 months in every year. So now our ratio would be written as 24 to 15. The second one, we've got 6 dozen to 80. We need to get the 6 dozen converted into just single units like that one. So we've got 6 times 12, which is equal to 72. And so we've got a ratio of 72 to 80. Now the second part says we need to always reduce them down. So going back to the first one, the 24 to 15, both of those can be divided by 3. 24 divided by 3 gives us 8, and 15 divided by 3 gives us 5. So that's our simplest form. In the one 72 to 80, the 72 to 80, both of those are divisible by 8, so we've got a ratio of 9 to 10. 72 divided by 8 is 9, and 80 divided by 8 is 10. So first you convert to having the same units, then you can write the ratio and simplify down to its simplest form. There are an infinite number of equivalent ratios for every other ratio. If we've got a ratio of 8 to 5, that's also the same as 16 to 10, or 24 to 15, or 32 to 20, and so on. All we're doing is multiplying both sides by the same number. Here we multiplied both sides by 2, here we multiplied by 3, here we multiplied by 4, and so on. Similarly, for the ratio of 9 to 10, we can have a ratio of 18 to 20, 27 to 30, 36 to 40, and so on. We can keep going. So there's an infinite number of equivalent ratios. It just means that both sides are multiplied by the same amount or divided by the same amount. Now let's look at rates. So what is a rate? A rate is a comparison of two quantities with different units. Another way of thinking it is it's a ratio with different units. For example, it costs $5 per pack of 6 cupcakes. Let's look at some more examples. We're going to look at this list here, and we're going to identify each one as either a ratio or a rate. So the first one here says 2 cups of flour to 3 cups of sugar. Is that a rate or a ratio? Note that we've got cups and cups. So we're comparing flour and sugar, but the units are in cups. So that makes it a ratio because we have the same units. The next one, 50 goals in 25 games, we've got goals and games. We've got different units, so that makes it a rate. So now this next one's a little bit tricky. We're comparing children to adults, but we're still comparing the numbers of people. So in that circumstance, it's going to be a ratio, where we've got the number of children to the number of adults. So the number of children humans to the number of adult humans. The next one, we've got 7 marks out of 10 marks. Both cases we're dealing with marks, so that also becomes a ratio. Next one says $6 for 12 oranges. We've got dollars and we've got oranges, so we're in different units. That makes it a rate. The last one, we've got 400 kilometers in 5 hours. We've got kilometers and hours in units, so that makes it a rate as well. So that's the concept of a rate. Now there's also something known as a unit rate. And all that a unit rate is that we take the ratio that compares a set number of units to exactly 1 unit of another quantity. For example, we can have 2 cats for every dog. So it's 2 cats to dog. It's the cats to dog ratio. But the key there is that it's 1 dog on the right side of the ratio, or 1 of whatever unit on the lower part on the denominator of your fraction. So it's a comparison of 2 quantities in which the second term is expressed per 1 unit. For example, the most common one is 40 kilometers per hour. So any rate can be rewritten to be expressed as a unit rate. Let's look at some examples here. If we've got 6 miles in 3 hours, we can get that down to a unit rate by dividing both numbers by 3. Dividing by 3 will get rid of the number in the denominator, which is what we want because we want to end up with 1. If we've divided the bottom by 3, we need to divide the top by 3. That leaves us with 2 to 1, so 2 miles per 1 hour, or 2 miles per hour. If you're typing at 40 words in 2 minutes, you can divide both the top and the bottom by 2, and you're going to get 20 words in 1 minute, or 20 words per minute. Similarly, if you go 5 miles in 2 hours, you divide both the top and the bottom by 2, you're going to get rid of that 2, but the trick here is that this time you're going to have a decimal in your final number. So you've got 2.5 miles per hour. Typically, we don't have decimals in our rates and ratios. The only time that we do that is when we are doing a unit rate. Let's look at some more examples. If we've got 50 goals in 25 games, we've got goals to games. So we're going to divide both the top and the bottom numbers by 25 to get the unit rate, and that gives us 2 goals per game. We've got $6 for 12 oranges. Divide both numbers by 12, we end up with 50 cents per orange, or half $1 per orange. If we go 400 kilometers in 5 hours, we divide both numbers by 5, and we end up with 80 kilometers per hour. When you're grocery shopping, particularly in places like the cereal aisle where there's a lot of products, you'll notice that they package them in all different sizes of package. Rarely do you see the same number of grams in a box of the food. That is done intentionally so that it's hard for you to compare which one is a better value. Let's look at how you would actually figure out which one's a better value, assuming you've got access to a calculator, because I can tell you they make the numbers so difficult, it's pretty hard to do in your head. So we've got 3 selections here: 500 grams for $2.99, 800 grams for $4.29, and 650 grams for $3.69. Getting to a unit rate means we want everything to be per 1 of something. In this case, we're going to say how many dollars to get 1 gram of food. So let's look at the Cap'n Crunch to start with. We've got 500 grams at $2.99. Since the $2.99 is the dollars, that's going to go on top of the fraction that we're doing. So it's the top of the ratio. So we've got $2.99 for 500 grams. We just divide that $2.99 by 500, and we're going to get 0.00598 grams. So that's dollars per gram. So you've got to spend 0.005, so a little more than half a cent will get you 1 gram of your cereal. You can also then do the $4.29, so that's also going to go on top for 800 grams, and when you do that math, you multiply it out, or divide it out, you're going to get 0.0053625. So that's a little bit less than what you're spending for the Cap'n Crunch. So your dollars per gram went down, so you're paying less to get the same amount of food. And similarly, we do the same thing for the Froot Loops. It's $3.69 for 650 grams, which when we divide it out is $0.00567 per gram. Sorry. I'm going to dig into that a little bit closer now. So we'll look at these right up close. So remember, the objective to start with here is going to be in finding dollars per gram. So that means we've got to have dollars on the top of the ratio and grams on the bottom. Dollars on the top is $2.99. Grams on the bottom, 500. And we do that division and we end up with 0.00598, and that's in dollars per gram. These were the dollars and those were your grams. Compared to the Froot Loops, here we've got $3.69 for 650 grams. Okay, so there's our dollars on top and our grams on the bottom. We divide that out and we get $0.00566 per gram. Here you've got 59 versus 56. So this, the Froot Loops, is costing you less for a single gram than the Cap'n Crunch does. You can also do the unit rate with the numbers reversed. So let's look at how that could work. We can say that you get 500 grams for every $2.99 that you spend. So in this case, we're doing grams per dollar. The way you're going to know whether you've got the right answer is if you're getting more grams for every dollar that you spend. So in this case, we can divide that out and we get 167.22 grams per dollar. So we get about 167 grams of cereal for every dollar that we spend. On the Froot Loops, we're going to get 650 grams for every $3.69 we spend. So there's our grams per dollar again. And if we do that math, we end up with 176.15 grams per dollar. So if you look at this, we're getting 167 grams for spending a dollar there, but we get 176 grams here. So again, our Froot Loops comes out as a better choice. Doesn't matter which way you do the ratio, as long as you're understanding what you're getting. Here we're talking about how many dollars did we spend to get 1 gram, and here we're talking about how many grams did we get for every dollar that we spent. You can work through it either way. As long as you know how to interpret the result, you can get the right answer. Try these on your own and then come back and look at the solution. So pause the video. So you've got 12 sunfish for every 30 rainbow shiners. That's fine, but you have to reduce it down. Both those numbers can be divided by 6, so we end up with a ratio of 2 to 5. In this next one, we've got 32 students, 20 are girls. But we're asked for a ratio of girls to boys. So before we can do anything further, we have to figure out how many boys there are. And there are 32 kids in total. Subtract the 20 girls, and we end up with 12 boys in the class. So our ratio then of girls to boys is 20:12. But of course, we have to reduce that down. Both numbers are divisible by 4, so we end up with a ratio of 5:3. Now this last one gets to more problem solving, where we've given a ratio of butter to sugar from a recipe, and it says it's 2:3. I'm going to do this as a fraction because it's a little easier to step right into the math that we need to do. So we've got 2 butter for every 3 sugar. It tells us that we've got 6 cups of butter here, so that's going to go on the top, 6, and we need to figure out how much sugar to go with it. Well, we're going to cross multiply here. We're going to go like this. So using our algebra skills, we can rearrange this to say that the question mark, our unknown value, is going to be equal to 3 times 6 divided by 2, which is equal to 9. So we'd have 9 cups of sugar. Here's another similar kind of problem. The ratio of houses in a neighborhood with dogs versus cats is 3 to 5. So for every 3 houses that have a dog, there are 5 houses that have a cat. How many cats would we expect to find in 90 houses? The first thing we need to figure out is what the total number of houses would be with this ratio, because this is dogs to cats, but here we're talking out of the total number of houses. So here we would have to say in total then there are 8 houses involved in this ratio. Then we're talking cats to the total. So we've got cats, which is 5, to the total, which is 8. So we've got 5 to 8 is equal to some number out of the 90. To solve that, our question mark, again using algebra skills, we would take this 90 and we would multiply across that 5/8 ratio. So we'd have 90 times 5 divided by 8, or you could do it as 90 times 5 divided by 8. And when you work out that, you'll end up with a fraction. You end up with 56.25. Now remember, we don't typically put a fraction like that, a decimal, into a ratio. So in this case, we would either round up or round down. It's a little bit closer to 56 because it's only a quarter. So we would round down. And so we would say that we would find 56 houses with cats. Here's 4 problems to try on your own. I'll reveal the answer, and then in a moment I'll dig down into the questions 3 and 4 to give you a more detailed explanation. So pause the video and then come back. Okay, so I'm going to give you the answers quickly. You can check your solutions and then stick around and I'll show you the solutions for questions 3 and 4. So we've got 2 choices. We've got either a 20-ounce bottle of soda for $1.80 or a 12-ounce bottle for $1.25. We're going to try to get that into a unit rate of dollars per ounce. So I'm going to take the $1.80 and put it over 20 ounces, and I get $0.09 per ounce, so 9 cents per ounce. Then for the 12-ounce bottle, I'm going to take that, follow that same approach, putting the price, $1.25, over the 12, divide it out, and I come up with $0.104 per ounce, so about 10 cents per ounce. So we're subtracting that, we can see that we're saving 1 cent per ounce if we go with the 20-ounce bottle. So it is the better value. Now let's tackle some bagels. A dozen bagels costs us $7.80. A 3-pack costs us $2.10. Again, we're going to use that unit rate to figure out which one is the better value. So it's $7.80. We want to figure out how many dollars per bagel. $7.80 for 12 bagels. We put the dollars per bagel, so dollars on top, bagels on bottom, and we end up with 65 cents. So that's 65 cents or $0.65 per bagel. And in the 3-pack, we do the same thing, $2.10 divided by 3. That comes out to $0.70 per bagel or 70 cents per bagel. So the dozen bagels is 5 cents per bagel cheaper. Your turn. Go tackle the homework.